Here's our new SkyFire 4-in-1 laser welder, cutter, and cleaner. This is a 2,000 watt unit. It got shipped over from SkyFire. And I'm going to go ahead and kind of give you a brief overview of this. So it came in pre-installed with the fiber bundle installed with the laser head. And the gun was also installed on the end of the fiber bundle. This unit is self-contained. It's got a chiller in the bottom, as well as the fiber source is down here underneath this cabinet. And up on top is the wire feeder itself. It's a completely separate unit. We'll take a look around here on the back side. What we're going to show you today is welding with steel only. This will do steel, aluminum, and stainless steel. But we're going to only show you steel, and we're only going to show you with compressed air. So we have our shop air coming in here. I put a regulator in here. Turns out our shop air at 125 psi is way too hot, way too much pressure for welding. So this regulator is down at 40 psi, and it runs back in there as well. And over here we have this is where you load in your wire. It's just like a regular MIG torch. We've got some 045 MIG wire in here from Harbor Freight. And down here we have some ER 4043 and some ER 5356. Like I said, we're not going to show you aluminum today because we're only been showing you steel. We've only been playing with the steel. We've had this laser about a week. So I'm going to just show you steel welding. In later videos, we'll show you cutting and as well as cleaning. But I'll go ahead and turn it on here. Power switch is over here. Our power, we're running into a 240 on a 30 amp circuit. And so both screens come on. These are both touch screens, and they really work well with gloves on. I know it's hard to believe, but you can have gloves on and touch them, and I just have no problems with touching them. This is the main screen over here. These are the settings you can change on your welding. I don't know if you can see this or not, but this is scan speed up here, scan width, peak power, duty cycle, and frequency. So you have 5 parameters over here to change, and then up here on the wire feeder, you have your feed speed up here. So you have 6 parameters to change on welding. So it's a learning process, much like MIG is, and stick and TIG welding. Over here you have 6 parameters to play with. Like I said, this is a 2,000 watt unit, so we're going to do some welding at 750 watts with our scan width at 3 millimeters. So that's the laser goes back and forth 3 millimeters itself. And then over here this is where you have some presets. You can set these up over here. And then this monitor tells you all this. This is the system status. It'll tell you, if your laser trigger, there's got some electrical contacts here, and all your power supply voltage is down here. So if there's any problem, you can come over here to this screen. Okay, so over here, the last thing is the chiller power is up here, and the laser power is down here. We're not going to turn this on until we're ready to go. Up here, this is the wire feed. We can just change this as a touchscreen also. So you can just press this and enter in your new speed. Okay, and you can also manually feed forward and manually feed back, and you can run and stop over here. So let's show you some examples of welding. We did a bunch of testing. We're mostly been using this 1/8 inch flat bar. Okay, and so this is our butt weld section here, and we kind of tuned things up and got this to look nice. And then we did T-joints here, and we have some various settings down here, and we've been playing around with this for, I don't know, 2 or 3 days now. Here's outside corner joints. Okay, see if we can do some of those today. And then at the end, I'll show you some welding 24 gauge and what it kind of entails. So I guess the first thing we'll do is we'll do a T-joint right here, I guess. Like I said, I think this is 1/8 inch. And what's amazing about this welder is you don't have to clean anything. You just basically hold it down and pull the trigger and it goes. So there's some safety issues that I want to kind of talk about. So right now I have the safety clamp. No current flows in this at all. But this safety clamp, I have this thing clamped to my table, and there has to be electrical connection between this wire, this clamp, and the tip of the gun here in order for the laser to be enabled. In fact, let me go turn the laser on. If these two aren't connected together electrically, the laser doesn't turn on. That's a safety thing. Look, if I want to point this right now, I get a dot. You can see I kind of get a dot here. But when I pull a trigger, it doesn't do anything. This is a low power dot. If I were to connect this up to this tube and pull a trigger, the laser light's going to come out of the end, and this is inherently dangerous. So we'll give you some examples of lasering, but we'll talk a little bit more in another video about safety issues with this, because we're learning as well. So I'm going to clamp this to the table, and these two are my two test pieces here. So like I said, I didn't clean these. Sorry about the fan noise, but so we're at 750 watts and the width of our laser beam is 3 millimeters. And I have my safety glasses on, and this runs at 1080 nanometers. And what I want you to notice, what's really interesting about this using a laser welder, let me wait for the compressor to turn off. Okay, so it's basically you point your red dot, you pull a trigger, and if the ground situation for the safety is shorted out, the laser will be enabled, and you basically pull a trigger. And what happens is the laser will start, and then a little bit later the wire feed will start. And you dial in your wire feed speed as well as your laser power, and the wire kind of pushes you along in the weld. I didn't really pull on it. All I did was kind of hold it in place, and the wire feeder was what pulled me along at the right rate. So what that does, I'll take some bigger, higher resolution photos of this, but what that does is it makes a very consistent weld bead, and there's very little heat affected zone outside the weld, but that weld it really penetrates well. Okay, so we'll go ahead and finish this weld off here. In fact, I gotta get my pliers to hold it, get a little bit hot. So I'll go ahead and finish off my weld here. Okay. So that's in there. That's a very fine bead. It looks nice, and you can't see the heat affected zone on the backside, but it's pretty much welded together. So if I want to do the other side, I can just turn it around and do the other side. Okay. All right, that's on there, and that's not coming off. It's pretty hot right now. In fact, you can't. I don't know if you can see this or not, but you can kind of see where there's a little bit of heat deformation on the bottom side of this 1/8 inch flat bar. All right, so that's a T-joint. Next one we'll do is something like this. So you got a flat plate, and it's okay, got a little thing right there. If I can work around that. There's a little, all right, here we go. Do it like this. All right, so we'll just weld this on. Let me move this over here. We'll just weld this on like this. And we're not going to tack it or anything. We're just going to go ahead and start welding it. Okay, that side's done. Okay, so that's two sides done. What was that, 20 seconds? All right. You can kind of see on the backside, we're getting some heat penetration down, showing up on the backside. And that's probably not coming off of there. So you get the idea there. I'll show you some bent pieces. I did some flat bar. I took like 2 pieces of flat bar and I did a T-joint on it. And then I took it over to the, I was waiting for that fan to get done. So I put a T-joint on a couple pieces of flat bar and I took it over to the device and I bent it up, and I'll show you what that looks like after the bend. And the weld just held fine. Okay, let's do a couple more here. Here's the angle for a square tubing, corner angle. And we're just gonna hold it. We're gonna go ahead and try to do a tack. I'll show you what it is to do a tack. So we got it like right here. And we're just gonna kind of put it down there and pull a trigger and put a little tack down. Okay, so that tack is in there. You can kind of see it there. Okay, and that's enough to hold it together. In fact, that's kind of high power for that corner. But it's together, you know. It's not coming apart. So we'll go ahead and weld this out. And same thing, you just pull a trigger and the wire feed comes out and pushes you along in the weld. Okay, so let's take a look at that weld. See, that's really looking nice. You got good heat penetration, and the weld bead's not very high, but the penetration into the metal is very high. So we'll do the other side. All right. It's the other side there. It looks like the metal got kind of hot. I'm actually probably a little bit hot on the laser because we started to eat away a lot of the metal. You can kind of see this here. The weld bead's up on top, but then down here it was eating away a lot of the metal, and the filler metal wasn't really filling in the weld. So we have to do some adjustment to the settings to get that. And I guarantee you, if we try to do this corner weld, well, I might as well try it, but we'll probably blow it out too. But let's give it a go. See what happens here. This metal's getting a little hot. Okay. So I ran off the corner, but you can kind of see that it kind of laid down too much stuff. Corners like this, you probably just want to fusion weld them. You don't want to do a wire feed. And fusion welding is a little bit of a challenge on this welder. So anyway, but you kind of get the idea of what it's like to use it. Now let's show you one last thing. It's a couple of pieces of real thin gauge. This is 24 gauge here. And so this one's a piece a little bit bigger. I'm gonna go ahead and bend it. Give it a little bend and see if I can get it to fit on this bottom piece down here. Okay, so I got this piece right here. So I'm going to weld this to that bottom piece. In my exploration for the week, I have welded a lot of things to my welding table. The laser is so powerful that a lot of times the weld actually went through my base material, and I did weld it, spot weld it to the table. But we do have some sample pieces, so I'm going to set this up over here for 1 millimeter, 200 watts. at 60 centimeters per minute. So let's go ahead and show you that if I can get my camera over here. All right, so I'm going over to the welder. I still got my gloves on. So we're going to change the scan width. So in order to change this, you come over to this technology button. You change the scan width to 1. And you change the power down to 200. Let me see here, 200. Come on. 200. I think we leave the rest of it the same. We do an import down here and go do a return over here. And we check our settings over here. So at 300 millimeters, this is the scan speed back and forth, 1 millimeter wide, 200 watts power. Okay, then up here, I want to change this to 60. So I just tap that, type in 60 here. Okay, now we'll go back over to the table. All right, so let's see if we can do this without burning through the, like I said, this is 24 gauge, which is really thin. We're just gonna go ahead and run a bead all the way around this corner, see how it goes. Let me move back a little bit here. And I'm just holding it down. I'm not gonna tack it or anything. I'm just gonna do it. Okay, you saw how fast that was. Okay. So you can see it's very tiny. We had a little problem pulling over here. We got a couple of bumps on here, but you can see the backside. We got really good heat penetration all the way through this, as well as over here. And if you hold this up to the light, you're not going to see through that. And so with this welder, it's capable of doing this really thin metal. You just have to, it's like any tool. You have to kind of learn how its intricacies and learn how to use it. But so this is what we've been playing with this week. Is there something else I can show you? Not really. So I'm going to talk a little bit more about some of my initial observations. Okay, like I said, we've had this laser for about 10 days. And for the initial first week of our euphoria, how excited it was, we did a lot of test pieces. And the quality of the welds is excellent. It's so easy, no cleaning, you just pull the trigger. But I have a bunch of first impressions I want to go ahead and get recorded. First of all, there's a bunch of extra parts you need when you get this from SkyFire. Primarily, the first thing you have to put a regulator on the airline. And that airline coming off the back is an 8 millimeter line. It's not a 1/4 inch or 3/8. It does change up to a 10 millimeter line, and I'm using a 3/8 inch push to connect to get it to go into the regulator. But you need one. At 125 psi, what was happening was the metal would melt, and then it would so much air pressure would blow the liquid metal out of the weld. Okay. Talk about laser safety first, other than just needing a regulator. So SkyFire supplies 1 pair of laser safety glasses. These are labeled right here on the lens. You can kind of see what the range is. This laser runs at 1080 nanometers, and this will protect you from reflected light, but not a direct hit from the beam. When you're laser welding, like you saw, all the sparks fly away from you, and also probably if there is reflections, they're also going to go away from you. So you need to be aware of that. If people are watching, everyone needs to have a pair of safety glasses. I have 4 pairs. I got 3 more additional ones from SkyFire, and just make sure that the people that are watching are not in the line of the reflection. If you get like this is a 2,000 watt laser, so it's inherently dangerous. This is a tool you have to really respect what you're doing. I'm wearing gloves. I also have on my welding shirt, and I wear my. I don't have it on today, but typically I have a one of these, a respirator mask, the Miller respirator mask. I wear one of these because whatever you're welding, if you don't clean it, you're burning off whatever that stuff is, rust or whatever. It's airborne, and that's basically it. I make sure I wear these. Unfortunately, I wear glasses, and I haven't seen laser welding glasses that are over the lens welding glasses. So I have to take my glasses off, put these on. I still have a kind of good vision nearsighted, so it's okay. But if you have to wear glasses because you can't see near, that's going to be an issue, and you'll have to find an over the glass, and I'll look around for it because I don't like switching them back and forth. These are easy to see through. It's not like welding. It's like a welding hood. You can easily see through this and see everything when the laser's not on without having to take it back off and on. When you're looking through here, the laser, the weld bead is actually really bright, and it's really difficult to kind of see what you're doing. But after a while, you kind of get used to what you're doing. So there's more on laser safety, particularly when we get to laser cutting. I'm going to go into why we haven't started looking at laser cutting, but I'm going to mark that one off. Next thing you want to be aware of is this fiber bundle here is probably pretty fragile. You want to make sure you never step on it. If you step on it, there's a chance you'll break the fiber bundle, and then it's probably expensive to have a new bundle put on. And so you got to be really careful about not stepping on that. So you want your welder, your table, or wherever you're working, it's got to be a clean work environment. We have it over here where we normally have a car parked in our garage, so we have a big lot of area to work around, and we're not stepping over things. We're not working in confined space. Okay, I'll mark that one off. One thing I never thought about with this, because you're basically using the wire coming off of here as your feed speed, you can only drag the torch, okay? And because of the safety system, let me wait for this to turn off. Okay, I just turned off the laser enable over here, and you can hear that there's contactors in there. I think that this switch here actually turns off the power to the laser source. So I'm going to turn this off now, and it'll be a little quieter in here. So you can only drag. I'm sure you could do other things with this. Fusion welding is something I'm not too successful with yet. I'll show you that once I do figure that out. But right now, if I wanted to use feeder wire, it's very easy to weld. You change some settings, you change your width, change your wire feed speed, and you just pull a trigger and it goes, as you saw there. Next item is touchscreens. Both the touchscreen on the wire feeder and the laser head itself are easily worked with gloves on. You don't take your gloves off. Even ones that have the seam along the tip, and I use TIG click level mostly, but you can just touch it, and it works really quite well. And when it brings up dialog boxes, the buttons are quite large, and you can hit those with your big fat fingers with gloves on. Okay. When you construct this and you put this together, one of the operations you do is you set this nozzle. This nozzle's got laser markings on here of distances out, and they're marked from, I think, -10 to +10. You set this at 0, and then you tighten up this feed here. Ours was kind of acting up a little bit, and we ended up not assembling this portion correctly. And what we ended up doing was we didn't get this set right. Now, so the laser bundle comes up through here, and then there's a actuation lens right here that makes the beam go back and forth. But the beam up here is wide, and it goes through a focusing lens right here, and that lens focuses it down to a point and comes out at the end right about over here. And we didn't have this quite set right, so what ended up happening was we have some heat discoloration in our tube here because we were a little bit too far out. And what that did was the laser ended up hitting the inside of our tube here. There's no damage to it, but just be aware that all the instructions are probably for these guns. This gun here is called a SUP 23T. It's a very common gun for laser welders. Another common gun is array tools, but we opted to go with this because this came as a bundled package. So this is used in a lot of videos as well. This wire feeder comes up here, and this is the part you have to assemble. Just put this on, put this tube in. There's some copper tips up here. These tips have different sizes, running from 0.8, 1 millimeter, 1.2, and 1.4 millimeters, depending on what kind of gauge of wire you're running through there. I think the largest gauge, we're on 1.2 now. You can't get bigger gauge wire than that at Harbor Freight, and so in order to go to 1.4, I don't know what that turns out to be in terms of wire gauge. But anyway, we're just using this because I had a spool around the shop here for my TIG torch. Okay, the fit up. When you do a fit up, it's ideal that the fit up is very good. You don't want to have big pieces. You don't want to put a big space in there. I've seen people weld fit ups that are not quite ideal together. That's another skill you kind of have to learn, but you can't. When when you're MIG welding, you could kind of stitch together the sides and have that bead hop across back and forth. You could probably do the same thing here, but you have to deal with the wire feed speed, and it's more of a challenge if your fit up's not very good. If your fit up's tight, then this thing works great. So you have to be cognizant of fit up much more than you do for MIG welding. All right. This is an interesting one. It took me about 2 days to figure out. So I rarely have to cut off the tip of my feeder wire, but because this is a tube and the wire gauge and that kind of thing. There's a little bit of there's ability for there to be a lot of slop in the wire. Okay, kind of see that I can pull the wire out, push it back in. It's probably about, I don't know, 8-10 millimeters. This feeder up here has the ability to do some retracting. And what was going on was I had a lot of problems with my wire getting tacked into the corner. And when I take the trigger off, my wire would still be hooked onto the corner. When you're on a MIG torch, you could just fire it and blast that last little piece of wire off of your weld piece. But this, you can't do that. So you end up breaking your wire across. So there's a little bit of skill on the dismount, I call it. On the dismount, on when you pull away and when you take your finger off the button. But that feeder will also do retract. And so what will happen is a lot of times when you pull it across, you pull this amount out so that you set up the retract, and you can set that in, I think it's in seconds or milliseconds on how much it runs backwards. And you can get this set up so that the wire ends up at the right spot for your next weld. Okay. Let's talk about what's next here. That was wire retract. Starting and stopping, that's another skill. When you start, you want to get the wire. Oh, my business partner came in. You got to get the wire underneath the laser, and when you pull a trigger, the laser will start. And then there's a little bit of a delay that you can program up here in here as well. Now, when you actually start the wire feeding, and so I don't know what the setting is, but you kind of hold it there, and then you can feel it's starting to push your gun. You have to have a light touch. You have a light enough touch that it keeps this continuity going, so that the laser source will stay on. But you 5 or 6 welds, you'll get a feeling of how the motion is actually going. Starting is easy. The dismount, or stop I call it, is a little bit more of a challenge because you're going to get to the end and you want to pull off and let go of the button at the right time. And because you're dragging, you can't see exactly when you should pull off your part. So stopping is a little bit more of a challenge than starting. It's just another skill that you have with these that's a little bit different than on a MIG torch. Okay. All right, here's another one that I learned the hard way. So let's say I'm going to weld something. Let's say I'm going to weld something like this, okay? And you got your gun down here like this. You got your little red dot down here. When you pull the trigger, the laser ends up popping off of here. It's still on because you've got the continuity, but the laser line actually misses your stock and goes over and hits your table. And there are several spots on my table that have little indentations, like my table melted, where the laser has hit it. Okay, it's not bad, but that's what makes the start interesting. Is you have an angle to work with here, as well as this safety system to kind of continue with. So starting is got a different set of challenges than stopping. But I definitely have tagged my table. And if you're welding steel, on my steel table, there's a really good chance you're going to weld your part to the table, which I've done a couple of times. That's why I have I got some bumps and stuff over here where I actually inadvertently did that. So I have a little sheet of aluminum that if I'm going to do something thin like this and I want to make sure it's not welded table, put the aluminum down and weld my steel, and the weld won't stick to the aluminum plate. Okay. Oh, that's particularly true where you're doing butt joints. If you want to do a butt joint on something, you lay it down on your table. And this is interesting. You're going to have to fixture it. So you want to just be aware that this has got a lot of power and it can actually melt all the metal together, including your table. Another issue with the fiber bundle, you want to make sure you don't kink it. This is a 10-meter cable, which is about 35 feet or something. And when you're pulling it like an extension cord, you don't want to get a really tight circle and just pull it out. You want to be very careful with the way that you drag your fiber bundle around. So you want to carefully lay it back onto the laser when you're done, and you don't want to you treat this a lot differently than you do electrical cord. Okay. And I've said that sparks fly forward. You want to get laser safety glasses for everybody. The safety glasses are actually too bright. I wrote these down. I'd like to figure out how to maybe get some laser safety glasses that have a little bit of darkening in them, like I would say maybe a 2 or a 3, like for when you do plasma cutting with at a 5, something like that. I want to see if that's something like that available. And then I talked about the over the glasses safety glasses. So that's it for my initial impressions of the place. Oh, I gotta conclude with our interaction with SkyFire. So we contacted SkyFire after watching Travis Mitchell's DIY 1000 watt fiber laser videos. He built one of these about a year ago, and he's just now getting finished on building his second version of that. And he had high praise for SkyFire. And so when you had a creator that says I didn't have a problem with them, we went with them. This is what SkyFire is that they're the system integrator. So they take the box, they probably paint the box, they did all the electrical work, they added a water chiller, they added a fiber source, they added this. And during the process of after our purchase, they went ahead and did some testing with our setup before they shipped it. And so we had a lot of pre-sale questions because we couldn't decide if we wanted to get a gun like this and be able to do laser welding and laser cutting, or just get a straight Raid Tools head and put it on an XY platform, like a plasma table, CNC plasma table. So we went back and forth. I would say we probably had 15 questions for, we were working with Fiona over there. And if Fiona didn't get the answer, she would get it almost immediately. Our time here in the Mountain Time Zone, about between 7 and 9, is their early morning in Wuhan. And it worked out really well. And I have to commend SkyFire, because the pre-sale support was excellent. And then after we got it, they're really receptive to hear any kind of feedback that we have. So the reason why I'm creating a lot of these videos is as a customer, I'm letting potential other new customers to something set up like this, what to expect when you get it. We went with SkyFire, and we had two options. We could get this shipped over FedEx, but then we'd have to deal with paying import duties. But we went with this other thing. Hey, Rob, what's that other thing called? Oh, he's not in here anymore. There's another way to get, it comes over in a boat, and the importer handles all the import duties and all that. So we got a fixed price. We didn't pay import duties. We didn't do anything. We got a door from SkyFire leaving their factory to our door. It was delivered right here. ABF dropped it off. And I'd say it took maybe 6 to 7 weeks to get here. And the tracking was excellent. We could look at where it was. We didn't know where it was when it was over the ocean, but the prediction of our box arriving on the 21st of July, was fine, and it took another couple of weeks to get here to where we are. So I would highly recommend working with SkyFire, just because I wanted a level of support. If I bought something like this off of Amazon, it might be cheaper. I don't know. Actually, we didn't want to consider buying something off of Amazon because we didn't want to have, if we had issues with it or questions about it, we wanted to have a support team behind us. And SkyFire is geared up now. They have a YouTube channel specifically for DIY people. So they're getting geared up for people that have a home shop or a limited production facility like we have here in our fab shop. And so that's their business model, as opposed to just being an assembler and shipping things out. The box that it came in, you saw an unboxing video. It was packed. There was no damage to the box. There was no damage in the inside packaging itself. So that's what I'm going to leave it there. In upcoming videos, we're going to talk about laser cutting, and we're also going to talk about laser cleaning. There's two cleaning modes. This is called a 4-in-1 system. So it does welding, which you saw. Cutting is just a straight cut. And our initial cuts are the cut width is like 8 mils, which is tiny compared to what we're getting out of our plasma cutter, and super clean. We'll talk a little bit more about that when we get to the cutting section, what we're doing. And then laser cleaning, there's two modes for laser cleaning. One of them is you replace this lens up here, which is focusing lens. And then you can get about 3 feet away from what you're doing, and the beam width will be maybe 6 inches wide, and you can take off a lot of surface dirt, rust, paint, whatever off of whatever you're kind of cleaning. The other mode is you put it in cleaning mode, and then all that's doing is putting it has a beam width over here, so you can use the cleaning mode without doing anything to the head here to clean off your welds. You can take all the contaminants that come out of the welding process and just blast them all away. So that's the fourth mode for this 4-in-1 laser system. So I've gone on too long now. I hope you found this interesting. And I will continue to kind of throw these together, and we'll go from there. All right. Thanks for watching.